Here in the second part of chapter 11, we'll focus on the chemical methods of control. So these include various liquids or chemicals, so they can be solids, liquids, or gases. Most of them are liquids or gases. So again, the solids, if they are being used, are usually dissolved in water to make it some type of mixture. And so we have a couple terms: aqueous solutions, that's one in which water is being used to dissolve the chemical, so it's called a solvent. Or we can have tinctures, and this is where it's dissolved in alcohol instead of water, or an alcohol-water combination. So again, they're solutions, they're dissolving the solid chemical or gases to make it a liquid. It's just whether water's used, it's aqueous. If it's more alcohol, it's called a tincture. Now, the desirable qualities here of these chemicals is a rapid action with not using a whole lot of it, so a low concentration, that it is soluble in water or alcohol, so it can be used and created into a liquid, that's effective against a lot of microbes, so broad spectrum action without any toxicity to humans, that it can penetrate those inanimate surfaces well. It's resistant to becoming inactive by organic matter, so like dirt or blood, something like that. That it's not corrosive or staining to that equipment being used, that it can sanitize and deodorize, and it's affordable and easily available. Now, a couple different terms here we talked about in the other recording. We talked about the types of instruments, like critical or non-critical items. When we're talking about chemicals, we have different levels of germicides. So a high level germicide, those are sterilants. So they can kill endospores. Again, they're sterilants if used properly. So these would be used, again, on critical items. They have to be sterilized, but they can't undergo heat. So they can't be autoclaved. So these are things like catheters, heart and lung equipment, different implants, for example. So high-level germicides would be used on those. Then intermediate level, these are going to kill fungal spores, but not bacterial endospores. They kill resistant pathogens and various viruses. So these would disinfect those semi-critical items like thermometers or respiratory equipment that comes into contact with the mucous membrane but doesn't move through it. And then finally, the low level, they're just used to eliminate only vegetative bacteria, different fungal cells, some of the viruses. So these are used on non-critical materials like straps or electrodes, furniture that's touching the skin, but again, not going through to those mucous membranes. So some of the factors that affect its activity. So again, just the nature of the microbe. Are we talking about an endospore? Is it resistant or non-resistant? We have to think about the material being treated. Can it withstand the chemicals? How much contamination is on it? So how dirty, how many microbes need to be removed, how long it needs to sit or be exposed to the agent, and then the strength in chemical actions, so how it works and how strong it is. Now, the targets for the germicides are similar to what we talked about with the physical method. So we're still altering proteins, altering the DNA or RNA, the cell wall, and the cell membrane. So that's the same whether we're talking about physical or chemical. Now, looking at some of the specific types of chemicals, one category are halogens, and this is where bleach, so this is a very common disinfectant in healthcare and many industries, but all of the chlorines, also iodine, can also be used, and bromine, fluorine, all of these kind of fall into this halogen category. So they are microbicidal and sporicidal. So again, cidal means killing. So they slowly kill endospores. So given enough time, they can be sterilants, and therefore they can also destroy all other microbes. So how they work is they combine with water to release an acid, and that denatures enzymes and proteins that make them unable to survive and go through their metabolic reactions. What it's used for Of course, disinfecting drinking water and sewage. As far as healthcare, though, we think about iodine for wound treatment, of course, not chlorine, but disinfecting as far as bedding and instruments can be used in the healthcare setting as well. Phenols or carbolic acid is another category. So these are going to target some bacteria, fungi, and viruses. They're made actually from distilling coal tar. So it's has an aromatic carbon ring. If you're familiar with your chemistry, there's a functional group. In high concentrations, they are poisons that can disrupt the cell wall, membranes, and proteins. So pretty much all of those cellular targets. At lower concentrations, though, they inactivate certain critical enzymes that are needed. So it can be used as a disinfectant during hand scrubbing, definitely surgical prep, and on lots of other medical uses as well. Chlorhexidine, this targets most, again, the same as the last, bacteria, viruses, and fungi. They have an organic base with a couple different chlorine and phenolic rings. They're going to target membranes as well as bacterial cell walls, as well as proteins that result in denaturation. So again, most of those targets that we talked about, chlorhexidines are going to target. And very similar to our phenols, those hand scrubs, prepping for surgery, can be used as an antiseptic and can also irrigate mucous membranes. Alcohol, so we think about this a lot as far as antiseptics, like before giving an injection or even on stethoscopes. Again, same targets, so most bacteria, viruses, and fungi. So it's colorless hydrocarbons, meaning they don't really interact a lot with water. Concentrations of about 50% and higher, it dissolves membrane. So again, the cell membrane, so it disrupts that surface tension and alters that membrane integrity. So it can be used as a germicidal and definitely used on degerming, so just removing those germs from the skin. So for just a little tidbit here, for all of these, it's easiest to kind of remember the differences. So quite a few of them, the targets, bacteria, viruses, and fungi, that's kind of the same. So you just kind of remember that. So I want to remember the unique things, like it is effective against endospores, or which ones target like most of the targets, which ones like alcohol only affects the membranes or it only affects proteins. Those type of things is what you want to kind of focus on, so it's not quite so overwhelming. Then our oxidizing agents. So again, we're back to those endospores. So this can be used as a sterilant. So this is where hydrogen peroxide would fall into. And how it works is the oxygen forms what are called free radicals. And those are very toxic to cells. So those free radicals that get released are toxic. So it can be used as an antiseptic, so on skin. So typically it's used on skin and wound cleaning. It's used a lot in mouthwash and bed sores, especially to treat anaerobic bacteria that don't like oxygen. Ozone can actually be used to control as well. So this is similar to peroxide, but ozone, again, it creates these free radical, these oxygen kind of radicals that are toxic to most cells. So typically used to disinfect air and water, not a lot for like disinfecting or sterilizing instruments or that type of thing. Then our detergents and surfactants. So again, bacteria, viruses, and fungi. This is also disrupting that cell membrane, and by altering the cell membrane, it ultimately leads to death because the cell kind of lyses and ruptures. So again, it can be used against a lot of different things, mainly or just for those low-level disinfections. So it's not a sterilant, but it can be used to treat those non-critical items, or a lot in like using restaurant equipment or that type of thing. Our heavy metal compounds, again, bacteria, viruses, and fungi. These germicides usually have either inorganic or organic metallic salts. So they have some type of metal, hence their name, that it's in it. So they can be in alcohol for tinctures. They can be in soaps or ointments, like zinc is a really common one. So mercury, silver, and other metals, they exert their effect by binding to functional groups, again, on proteins. So that's their target, is altering the shape of those proteins and activating them, again, causing damage to the cell. So these are good for antiseptics, also preservatives and cosmetics, or eye solutions, or again, topical creams and ointments. Our aldehydes, this was another one that kills those endospores and therefore everything else. So it has the CHO functional group on it. So glutaraldehyde is one of the main ones that we talk about. It irreversibly disrupts enzymes and proteins. Again, it denatures them, causes them not to work, so therefore they die, they can't survive. It is broad spectrum. It kills a lot of different things. It can be used to sterilize respiratory equipment, different scopes, dialysis, and various machines or equipments used in medical fields. Then our gaseous sterilants and disinfectants. Ethylene oxide is a sterilant. It does kill those endospores. Other gases, though, are not quite as effective, but ethylene oxide is one that is a sterilant. So again, it exists as those gases at room temperature. It works by altering the nucleic acids in proteins that again inhibit the cells from functioning, and typically used on plastic materials that can't withstand some of the other treatments, or delicate instruments to sterilize, like syringes or surgical supplies that are prepackaged. They're usually treated with ethylene oxide. And finally, our acids and alkalis that alter pH. Again, bacteria, viruses, and fungi. This is mainly just used as acids in food prep, and they're just changing the pH that alter those proteins. But again, typically not used in healthcare. This is more in food or deodorants or deodorizers. So again, just a reminder for these, kind of go through, because it can seem like a lot, just kind of hit, pick out the ones that are unique. So which one kill endospores, and then just know all the other ones are bacteria, viruses, and fungi. Which ones affect proteins, which ones affect membranes, which ones, affect the cell wall. Those types of things are kind of what you want to pull out and highlight.